Hello students, in today's video we are going to discuss about the standard SOP form. As already discussed in our previous video, that any Boolean expression can be just written in an SOP form or in the POS form, that is in the sum of product form, and or in the product of sum forms, because these are the two standard forms to write a Boolean expression. Now the thing is, like in our previous video we have just discussed, or we have just seen what a sum of product form mean and how to write a Boolean expression in an SOP form. Now basically it is important to write the Boolean expression in a standard SOP form. So what is in standard SOP form, or we also say that it is also known as in canonical form. So how to write the SOP form in a standard form, and what is a standard SOP? Basically, a standard SOP expression is one in which all the variables in the domain appears in each product term in an expression. So suppose, for example, I am taking here an example of an SOP. If you will see, like here we have A or A complement B. This is a Boolean expression which is in an SOP form, sum of product form, because we are having the product terms. A is a single variable here, and then we are having A complement B. A complement B is a product term in itself, and then we are having a OR in between them. So this expression is in an SOP, but we cannot say that it is in standard SOP form. We have to convert it into the standard SOP form. So now because in A, in the first term here, we don't have the term B. If you will see, the full domain of the expression is A and B. We are having this term defined on two variables. The variables are A and B. But in the first term of the expression, the B term is missing. In a standard form, every term should include all the variables included in the domain. So therefore that means we have to somehow convert this A into two variables. So how can we convert it into two variables? Because the domain of this expression is 2. That means we are having this expression in two variables. So how can we convert it into the two variable, this first A? We can just apply the law of Boolean algebra, which is A or A complement is always equal to 1. So if I will multiply this A with A or A complement, it is not going to have any change. So now I have just multiplied here this A with B or B complement. Then the next term will be same, that is A complement B. So when I will further solve it, it will be equal to just applying the distributive law. I'm just simply multiplying this. It will be A and B, or A and B complement, or A complement B. So if you will see this, it includes three terms, but all the three terms have both the variables present, whether in the complement form or in the normal form. That doesn't matter. But the thing is that all the variables should contain all the terms should contain both the variables. So therefore this we can say it is in the standard form, because in the first term A, B both are present, in the second term A, B complement is present, in the third term A complement B, that means A, B variable. These expressions are important in constructing the truth table and forming the cannot map simplification methods. So this simple cannot map and the construction of truth tables, we will take this in our next upcoming videos. So they are basically used in simplifying the cannot maps. Now we can have any non-standard SOP expression, and any non-standard SOP expression can be converted into standard, or we can say the canonical SOP expression. We can simply convert it by just applying the Boolean law, which is what a non-standard SOP expression is converted into standard form using just the Boolean algebra rule. A or A complement is equal to 1. So now we will take an example and just try to solve that. I mean, we will take an example which will be in the non-standard form, and we will just convert it into the standard SOP form. Now, okay, so let's take an example. Like, we have converted the following Boolean expression into standard SOP form. The expression is A B complement C, or A complement B complement, or A B C complement D. Okay, now if you will see, the domain of this expression is 4. How is it 4? Because in the last term we are having 4 variables. We are having A, B, C and D, but D is missing in the first term, and in the second term C and D is missing. So we cannot say that this is in the standard SOP form. We have to convert it into the standard SOP form. So that means we can simply write first that I can write it like the domain of this SOP expression is A, B, C and D. That means I have to somehow include the D in the first term, and in the next term I have to include the variable C and D. So I will take first, I am going to take the first term. I will take, my first term is here A B complement C, right? So this is my first term, A B complement C. I have to include somehow D in it. So how I am going to include D in it? I will just simply apply the Boolean law, which is A or A complement is equal to 1, because 1 multiplied or I can say 1 and with a variable is always equal to the variable. That is again a law. So if I will write here A, D is missing, so I will write D or D complement. Okay, so that will be equal to A B complement C D, or A B complement C D complement. Okay, so that means my first term, which was A B complement C, is now A B complement C D, or A B complement C D complement. That means I will replace this term with these two terms, but these are now in the standard form. Okay, now I have done this for the first term, but if you will see my second term, I will write it as my second term here is A complement B complement. So how I am going to convert it into the standard form, as C is missing in this term and D is also missing in this term. Yeah, so first I will write it as, it can be written as A complement B complement. I will AND it with C or C complement, because C or C complement will be equal to 1, and 1 multiplied by A complement B complement will be equal to A complement B complement. That means it is not going to make any difference, but yes, my expression will come in the standard form. Okay, So this is going to be equal to A complement B complement C, or A complement B complement C complement. Okay. Now if you will see again, the term D is missing because our domain of the SOP expression is in 4 variables. So we have to again do it as, we have to again multiply these both terms with the law. So we will write it as A complement B complement C multiplied by D or D complement. My D or D complement will be again equal to 1 according to the Boolean law, and 1 multiplied by A complement B complement C complement will be equal to A complement B complement C complement. Okay, so and or the next term, this one, so I will write it as A complement B complement C complement again and with D or D complement. Okay, so this is going to be equal to A complement B complement C D, or A complement B complement C D complement, or A complement B complement C complement D, or A complement B complement C complement D complement. So that means I have just converted this second term into the SOP form. So A complement B complement, this term in an SOP can be written as A complement B complement C D, or A complement B complement C D complement, or A complement B complement C complement D, or A complement B complement C complement and D complement. Okay, so that means, and finally my third term, which is in a standard form because all the 4 variables are present in it, so it is already in the standard form. I don't have to do anything with this term. So my final expression in standard SOP will be equal to this first term, A B complement C, will be equal to A B complement C D, or A B complement C D complement. Okay, my second term, now this A complement B complement, this will be equivalent to this. So I will write here, it will be equal to A complement B complement C D, or A complement B complement C D complement, or A complement B complement C complement D, or A complement B complement C complement and D complement. Okay, and my third term, this will be written as it is A B C complement and D. So now if you will see that this whole term, this is in the SOP, standard SOP form, because all the 4 variables are present in each term of an expression. So this is how we convert a expression which is in the non-standard SOP form in the standard SOP form by just applying the simple Boolean law, which is A or A complement is equal to 1. So okay, thank you.